Let's say this request to a web application can delete a user's account. Is this a secure implementation? Well, let's talk about this. The answer is not really, because what if another website sends the exact same request cross-domain? How would the server actually know where it came from? To put this into a better perspective, I'd like to start with some fundamentals and then move on into the actual stuff. Consider this scenario. There's a simple web application. Upon logging in, you get some cookies, as usual, which are going to be stored in your web browser. Now listen to the following sentence very carefully. Whenever you make a request to this web application, the cookies in the browser are sent automatically so that the web application can verify your login. Now let's switch gears and talk a bit about cross-domain access controls. As you know, in HTML, we have iframes, which basically lets you embed one website inside another. But the cross-iframe communication is not possible due to something called as same origin policy. This is a security feature which makes sure that an attacker's website can't just make requests to arbitrary websites on the planet and read data cross-domain. This is very important because of the fact that cookies are automatically sent on every request you make to that domain. The policy only lets you read from the iframe if the following three conditions are met. Firstly, same domain. Second, same schema. Thirdly, we have same port. If all these three things are the same between the iframe and the website, only then the browser lets you read cross-domain data. This does not just apply to frames, but it also applies to other things like AJAX requests. Now that you know a bit about the fundamentals, let's continue our journey with CSRF attacks. First off, CSRF stands for cross-site request forgery, which means one domain is making, or more accurately, forging request to another in order to modify some value. For example, let's say we have a website called vulnerable.com. And clicking on the delete button actually deletes our user account. Now, we don't want to do that. And let's go and click on another link, which is cat.com. Who doesn't like cats? Best website in the world, right? No, you're wrong. In fact, it just became your nightmare. It basically deleted your account on vulnerable.com just by visiting cat.com. Let's break this down so that we can understand it a bit more. You've logged into your account on vulnerable.com and you have some cookies saved in your browser, same as usual. If you click on the delete button, it will send a delete request to this endpoint, vulnerable.com/delete my account. But when you visit cat.com, there was a request made to the exact same endpoint, vulnerable.com/delete my account. But it was made from cat.com. And now, remember what I told you earlier. On every single request, the cookies are automatically sent to the website regardless of your current domain, unless there are some flags set to it, which we're not going to talk about. But anyways, this means that a delete action happens in the context of your session, ultimately deleting your account forever. So in short, cat.com forged a delete request to the vulnerable.com. This is CSRF, or cross-site request forgery. This is an old vulnerability, it's been here for a very long time, and there are proper protections against this. And one popular and widely accepted solution is by using randomized tokens, which are also called as anti-CSRF tokens. This will be generated randomly by the web application in the backend and sent to the website. On every request, it's validated, so that the other website can't make cross-origin requests or cross-domain requests because of the fact that it doesn't have any knowledge about this new token. Earlier, I also talked a bit about same origin policy. The reason for this is because I wanted to make a point clear. By doing CSRF, there is no same origin policy bypasses. which means we're simply making requests to other websites, which are totally allowed, but we can't read the responses, which is basically blocked by same origin policy. But again, no rules of same origin policy is broken. Now that we know the idea behind this attack, we can take a look at the code behind cat.com to understand everything a bit more. As you can see, we have a form, and the action of this form is set to delete endpoint of the vulnerable application, and the method is set to post. One additional thing that you can see is that there's some JavaScript which submits the form automatically, so that there's no user interaction or whatsoever. In addition, instead of form submissions, you can also use JavaScript to make AJAX requests in the background so everything happens asynchronously. Simple, but not always. Sometimes the web server will be expecting some JSON value because we see a lot of APIs these days, and it's very common for you to find CSRF with some JSON in it. As you know, in HTML, the normal post request is going to be through a form, and usually post data, when it comes through a form, has the generic key value pair, but not JSON. If you think about how these post parameters are created from the HTML elements, you can actually figure a way around this. Suppose we had an endpoint called /deleteItem, which takes a JSON post data and deletes the specific item. As you can see, we have some JSON data here, and we need to send it over to the website as a CSRF attack. But how can we send JSON data using forms? Because form submissions are not JSON stuff, right? You can pause the video for a second and try to think about how you can actually make it JSON. Alright, let's create a simple form to try this out. If we set the name of the item to something like Apple and send a request, we can see what's actually going on. As you can see, the majority of the string is controlled by the user. So let's try to craft something that looks like JSON. In the left, you can see the item name and the value, which is Apple. But we need something like this, a proper valid JSON string. Now, let's go step by step into creating from this to this. First off, we need some curly brackets. We can simply replace the item name to our JSON string. As you can see, we are already a lot closer. We have everything we need, but there's one more thing. It's not really a valid JSON data. As you can see, there's some text at the end which mean nothing. So in order to get rid of this, you can make them as comments. But wait, JSON doesn't support comments, right? Well, it doesn't, but in Ruby, it's actually a thing. Comments are kind of allowed. So you can simply add 2 forward slashes at the end and get this working. But hold on a minute, what if it was not Ruby? What if there was no JSON comments? Well, we might have to think a bit differently. Since we also control what's after the equal sign, we can kind of make this work. We can simply add another key value pair in this JSON string, which doesn't mean anything. We can simply put it as junk and make this a valid JSON data. As you can see, this part is the first part, which is the name of the HTML element, and this part is the value. The equal to sign in the middle goes into the string equals test. Now this entire thing is a valid JSON string. When this is passed, everything works, only the item name is pulled out from this JSON object, and the junk part is ignored. There we go, that's a simple way. But there's also another simpler way of doing this, and that is by using AJAX request. You can simply use fetch request and send the JSON string as the body. A lot simpler, I know. As usual, we're going to get the same origin policy error, but we don't really care about this because the request is going to hit the server, and our update actions is going to happen, regardless of the output. The form and the AJAX way that you just saw now only works if the content type header is ignored by the server. But many times you'll find yourself that these content type headers are actually required for this to work. Sometimes the web application might be expecting a content type header being set to application JSON, which indicates explicitly that we're dealing with JSON data. Now the thing is, we can't just set another header in the form, but we can set this in JavaScript, but there's still a problem. The browser doesn't just allow you to set any headers you want unless the server explicitly lets you do it using CORS. Now, what is this? What is CORS? CORS stands for Cross-Origin Resource Sharing, and this is basically a bypass for same origin policy. In a good way, of course. This is only allowed if the server explicitly lets you. This feature is quite useful than what you think it might be because of the fact that APIs are all over the place. And usually APIs are going to be hosted in a different domain from the one that's actually making requests. In these kinds of situations, it's necessary to have a proper way to communicate between different domains. Coming back to this CORS thing, you can only set the content type header if the server sends back your domain and the header that you want to set, which is content type, in the response header. To be specific, it's access control allow origin and access control allow headers. Only then it's possible for you to make JSON CSRF request with the content type header being set to application JSON. But there's another way of actually making this work without using any of these. And it's by using Flash. No, not the one from Justice League, but, if we had them, it would have been a lot easier to hack stuff, if you know what I mean. Anyways, getting back to Flash, I mean the old Adobe Flash. Remember one of those? Is that still a thing? I don't know. In about a year, it's just gonna completely vanish, pretty much. But yeah, Flash files, they can help you in this case. Flash files aren't directly affected by the same origin policy because they have their own thing. And I'm not going to get into details, but you can look it up on Google and do your research, I guess. But again, you can forge the content type header using Flash files. But the thing is, the cookie won't be sent along with it unless we have that cross-domain XML and other things, which we're not going to talk about. But in order to make this work, we can do a simple redirect, like a 307 redirect, which holds the headers that are actually being sent, acting like a relay. So the basic idea is that we add a content type header in the Flash file and all the JSON post data that we want to send. We also specify the request endpoint, which is not the vulnerable.com, but instead to our 307 redirect page, which in turn redirects to vulnerable website. Now, this will receive the headers like content type header and also the post JSON data as a string and forward it to the vulnerable.com, ergo JSON CSRF, with appropriate header set. Sometimes CSRF could also be chained with other bugs to get it to even more critical vulnerability. In fact, last week I found one such case, where a CSRF helped me to get a remote code execution. Wonder how? I won't go into details, but I'll leave a link to the GitHub issue in the description. So, CSRF is still a thing. Not too common though, but they're still out there. Waiting to be found. Sometimes, even if there's a CSRF protection, there might be other ways to figuring out. Maybe another endpoint is leaking it, or the CSRF token itself is predictable. So, be on the side of alert, because you never know what you're gonna find.